Let's get kicked off. A few of you are still joining. Thank you so much for being here. I just posted some of the instructions for the hands-on labs, which we'll go through later in the chat. And this will be recorded. So if you're just joining, no worries, you will be getting this recording after. But let's get started in the interest of time because we have a lot of material to go through and want to make sure that we give it its fair due. So next, please. I'm going to take us through a couple of housekeeping details just as we get kicked off. The first thing to note is that there will be no chat functionality during this session. We found that it's very distracting and that it actually impedes progress during the labs. Instead, we have enabled Q&A functionality, so please feel free to use that. We have excellent solution architects from the Databricks side who will be monitoring throughout this session and answering real time. If we have time at the end, we also plan to leave about 10 minutes to address any outstanding questions. I just launched the welcome poll. Please take it. It should take you less than 10 seconds. It's 3 questions, and we'll do the same at the end. And the whole purpose of that is just to continue making sure that we're tailoring this for you all and making it as impactful as possible. And then a reminder, the slides and the recording will be sent to everybody who's attending this session via email. After probably like about 48 hours, we produce it and put it all together so that you can practice at your own pace. This would also be a good time if you haven't looked at the chat to sign up for free editions so that you don't have any hiccups when we're actually launching the labs after the keynote portion of this presentation. Next slide, please. So a quick look at our agenda for today. I'm going to be kicking us off. I'll take us through a little bit of background on Databricks for those that might not be as familiar. And then we're going to turn it over to Brian and Sumia, who are our colleagues at Google Cloud, to walk through our partnership and integrations there. Before turning it over to a set of excellent solution architects from the Databricks side who will be walking us through hands-on labs that you can work on with us directly. And then, as I said, we'll try to leave about 10 minutes for Q&A at the end. Next slide. Here is our speakers, starting with me, Bonnie Peterson. I'm a senior manager of partner marketing at Databricks, and then I will be turning it over to Brian and Sumia again from Google Cloud. Next slide. And next, let's get right into it. Next slide, please. Okay, here's our snapshot, our beautiful snapshot of Databricks. So hopefully all of you know Databricks is a data and AI company. Our mission really has always been to democratize data and make sure that it's accessible to everyone. And that's not just the technical users. We're also consistently looking for ways to make it accessible to the business user. And you'll see later in my presentation some of the exciting new products that we have rolling out. But overall, like openness is at the heart of our strategy. So when you're looking at Databricks, we're very flexible. We have open standards. We're trying to ensure flexibility and a seamless integration with third-party tooling and just make overall data sharing collaborative. We're trying to break down silos, break down barriers to make sure that enterprises and companies are getting the most out of the data that they do have. And you can see that that's true to our core because our founders actually created many of the most successful open source projects. You can see Apache Spark and Delta Lake and MLflow. Additionally, we're pioneers in the Lakehouse model, which we introduced in 2020, which combines the benefits of both data lakes and data warehouses, which creates this unified approach so that we can really govern, manage, and access data from a unified layer. At this point in time, we have over 20,000 global customers. And if you saw the earnings last year, we hit over 5.4 billion and growing. So we're very excited to see where we go next. And so Databricks really believes that every industry is going to benefit from AI. When you look at it across the industries, we're already seeing transformative impact across our customers in every single industry that we service. But the truth of the matter is reality to getting these things into production versus like the vision is actually pretty difficult. Next slide. And organizations are continuing to struggle. And when you're looking at that and you're trying to figure out what is the core challenge, it's really the architecture. And you'll see why on the next slide. It's fragmented. So you're looking at what a typical enterprise may look like. Every single piece of the organization has a different software vendor, a different agent that's built in. They're not talking to each other. They're in complete silos. There is no enterprise-wide data context that's happening. They're getting inaccurate results. They're not able to trace where the data actually came from. And this is creating a lot of issues when we're actually trying to move a transformative, innovative product into production for these enterprises. So we tried something different at Databricks, starting with Lakehouse, which I mentioned up top, which we launched in 2020, then developed Lakebase, a serverless Postgres transactional database, and Lakeflow for ingestion. But the core concept that I mentioned up at the top is really this unified governance, which is underpinned by Unity Catalog. Next slide. Thank you. Because that gives you governance, visibility, and semantics across all of your assets, all of your data. So if you look at this, you're thinking one catalog, one set of permissions, one audit trail, one semantic layer, common language. That's making it all possible to gain these insights from your data. Next. And that's across all of your assets. Next. And so this is what I wanted to bring up, because one of the ways that we're doing this now and we're really excited about rolling this out is through Genie. So this is a conversational interface more geared towards business users. If they don't want to learn SQL, they don't have to. You can now go in, easily ask a question. Next slide, I want to show the demo actually for this because I think it's exciting. And literally ask any question that they want to get answered about the data that you have at your disposal in natural language to get back insights. So we're really excited about this. This is opening up a huge door in terms of who can actually access the data and drive real impact within the organizations. And if you haven't seen it yet, highly recommend checking it out, looking into it a little bit more and testing it out yourself. I'm now going to hand it over to Brian, who will share more about our Google Cloud partnership.
Great. Thanks, everybody. Quick snapshot of the partnership. My name is Brian Bokel, and I manage the global partnership for Databricks. The partnership is quickly growing, 2,000 plus joint customers. We've been active as a partnership since 2021. Databricks on Google Cloud is available in 15 global regions, offers serverless options in major regions, and includes native Gemini support. Fundamentally, it's cheaper to run Databricks on Google Cloud due to the lower cost of DBUs and optimizing infrastructure like virtual machines and storage. Running Databricks on our ARM-based Axion C4a VMs delivers 40% better price performance than previous generations. And Databricks has been Partner of the Year of ours for the last couple of years. Next slide. And the key pillars for the Databricks and Google Cloud include unified integration, a commitment to open source, price performance, and access to AI services. Combined, this offers a powerful and flexible data platform that streamlines the data engineering, analytics, and AI workloads. Integration includes services like identity and access management, cloud storage, BigQuery, and then, of course, unified billing through the Google Cloud Marketplace. The open standards approach tightly integrates with Google Cloud services, and unified data experience make it a compelling choice for companies looking to build a modern data architecture, which you're going to hear more about through today's session. Removing the data silos and leverage the integrated one data platform, reducing costs and driving efficiency, efficient data sharing and ingestion, and accessing, of course, the native Gemini and agent platform integration. Databricks on Google Cloud combines the best of the data warehouses and data lakes, allowing users to handle both structured and unstructured data in one place. This unification simplifies data management and allows for more efficient analytics and AI workloads, and that's why we're all here today. Sumya, I'll hand it over to you.
Thank you, Brian. I will just move on to This is basically a workshop that we conduct, but for this session, we will just cover some basics about agentic stack on Google Cloud and how it complements Databricks in a pretty seamless way, and how you can leverage both the Google Cloud and Google Cloud agentic platform and Databricks to complement each other. Next slide, please. Thank you. So we'll start with basics of what Databricks stack is, what the Google stack is, and how they uh, like uh, complement each other. So Databricks on Google Cloud is intentionally designed to complement native GCP services. There are the Google Compute Engine, the identity access management, and then we provide the secure access to all the systems and simplified deployment. This creates also the open data lake featuring built-in connectors with both GCP and Databricks. So if your data is in Databricks, you can host the Databricks on GCP and then seamlessly use the Google agentic platform, Gemini, and various other tools that I'll be covering shortly to harness the power of the data that is there in your data lake or data warehouse. Next slide, please. Um, so our AI platform is essentially, as you all know, based on Gemini. We have the Google's agentic stack. We have and I'll be going over each of these separately. ADK is the agent development toolkit. It's a SDK meant for agents. Model context protocol was popularized by Anthropic, and we have embraced it fully. Today, Google runs more than 120 plus hosted MCP servers, and you can always build your own MCP server if you want uh, to interact with the various applications that your agents need to. And then we have the agent engine where you can deploy your agents. The A2A protocol, which again is Google native, allows the multi-agent orchestration where you can use the protocol to interact with the various agents that you have in your system. Um, and then uh, we also ensured that there is uh, like a extremely low latency for the infrastructure that we provide, and our infrastructure is spread across all the different geographies and platforms. Next slide, please. So this is our agentic stack, which I was just briefly speaking about: the ADK, the MCP, the Gemini Enterprise, and the A2A protocol. Next one, please. And this is the overall Gemini Enterprise agent platform, which we just announced. Some of these are pretty new, as you can see, which were just announced at Next last month. So for builders, we have the agent development toolkit. You can also use third-party agent frameworks. You can use like LangChain, Llama Index, any open sources. You can use the Gemini models for sure. You can use any third-party or open models as well. And then we have the Agent Studio and Agent Garden, where there are a lot of like pre-built agents which you can use readily, kind of out of the box, or you can obviously build your own agents. And then we have all this set of tools and data and other agents that you can use seamlessly on the data that you have. For scaling, we have the agent runtime, agent session, sandbox, and memory bank. For governance as well, agent governance is one of, I'll say, the hardest topic for now, because it's very debatable what's the right way to govern your agents, and we have multiple frameworks around that. And then for optimizations, again, we have the observability and the optimizer for different agents. You can simulate your agents and you can figure out what works best. Next slide, please. So I'll start with the agent development toolkit. So uh, the Agent Development Toolkit is a client-side SDK. Is designed to define multi-agent applications, orchestrating different actions among multiple agents and tools for when you have a really complex real-world situation. ADK provides you with a pretty intuitive UI where you can very quickly iterate by, you can visualize the agent topology, you can trace what are the actions that are happening, and then you can very easily interleave multiple code logics, and you can use the Gen AI reasoning to build even hybrid agents. As I said, Gemini is the default, but you can use any generative AI model. If you have your own fine-tuned model, you can use that. You can use like models which are grounded in RAGs, which you have custom built for yourself. Next slide, please. So these are some of the core concepts for ADK, and basically what we have is we have the agents, which are the core building blocks. These are powered by LLMs so that the agents can reason, they can plan, they can use tools. And then we have the agent tools. These give the agents power so that they can interact with the external APIs, and they can search for information, they can run codes, they can do all the good stuff that they're supposed to do. We have the sessions. The sessions are, they handle the context of a single conversation, including the history. And we all know that session is pretty important for the context of agent, because if the agents doesn't have the context in a particular sessions, then the next steps become hayward. Then we have the runner. This is the execution engine that manages the execution flow. It orchestrates the agent interaction, and it coordinates with the backend services. We obviously have artifacts management, callback, but I'll skip that for now. Next slide, please. So coming to how you can like use ADK concept for building agents. This is the syntax that we use. So when agent processes a request, it basically performs a LLM call for reasoning and for tool selection, and it's followed by a function call where the framework actually executes the tool. We can define these agents, and it requires really very minimal boilerplate code, and these codes are all available. You can easily find them, and you can easily build your own agents using this. Next slide, please. So this basically the previous one, actually, it basically shows how you can easily build a flight agent to coordinate other tasks. So the ADK concepts, the tool which we have, the platform that we have built is we have the processing request, then the LLM calls for the selection, then the arguments, and then the framework, and then the agent processes the result, and then the final response is sent over to the user. Next, please. So this is a sample of how you can easily get like a weather report, and you can use pre-built functions that Google has, like you can use Google Maps, Google Search, even Google Weather, and then you can use those within your tool. You can import the required function tool, and this shows how you can get the weather based on a city that you have. Next, please. So like I was mentioning, these are minimal boilerplate codes that you have, different agents. This is a travel booking agent. It calls the flight agent, then it calls the search flight agent, and then it returns the result to the user. So this is an example how by very simple building blocks, you can actually build an fully functional agent pretty easily. Next, please. So there are three ways of running ADK agents. Obviously, one way is to run it on ADK Wave. It's inbuilt development UI is easy to visualize agent flows and traces. It handles the sessions automatically, but this is not great for production. This is all good for your own iteration and experimenting. The second way of running it is a programmatic way. So you can run via very standard Python scripts, which are meant for production. You can manage the sessions and the runner manually from there. And then finally, there is the CLI for very quick testing directly in your terminal. Next slide, please. So now it comes to basically deploying your agent and sorry. So this is how ADK Wave looks like, which I was just covering. Next one, please. So now it comes to the deploying your agents. So you have built your agents. You can deploy it to either a Vortex AI agent engine. You can deploy it to Cloud Run, or you can deploy it to your own custom infrastructure. Like it can be Docker host, it can be GKE, it can be on-prem, and the entire thing can be containerized. Next, please. So now we'll very briefly cover some agent tools. So these are the tools for agents. So we have some pre-built Google tools, which are ready to use, like Google Search for web access, Vortex AI Search for RAG. Actually, we have also come up with like the vector search on Spanner as well. So a lot of the times today, one very important concept is how you can ground your agent and provide more context. And very critical concept for that is building a RAG, retrieval augmented generation, and one of the most promising or established way of building RAGs is to build a graph RAG and then ground your agents on top of that. So you can have your data on Databricks, and then you can use Spanner as your like graph database, which is infinitely scalable, similar to Databricks, and then use the power of both Databricks and Spanner to build your graph RAG and then ground your agent on top of that. You can use any third-party tools like popular libraries like LangChain, CrewAI, Llama Index, and you can obviously use your own custom tools. You can turn your own Python functions into a tool or connect to proprietary APIs as well. Next, please. So Google Agentic Platform provides native support for all the agentic protocols. The two most important one are MCP, Model Context Protocol, and A2A, Agent-to-Agent Protocol. The main difference between these two is MCP provides context to the various APIs and tools that your agent is connecting with, while A2A provides the protocol for agent-to-agent collaboration. When you have a multi-agent system and you are orchestrating a very complex agentic framework that needs interaction between multiple agents, then the A2A comes into play, and then you use MCP to provide the context to all the external tools and APIs. So with the help of both of these protocols, the MCP and the A2A, you can build whatever you need to for your entire agentic stack. Next slide, please. So I'll basically, like I said in the beginning, this is normally followed by a hands-on lab where you actually build agent using an MCP and A2A. But for today, I'll end my session with a little overview of MCP because that's one of the most popular concept where what everybody is eager to learn. So MCP, think of it as like you have a hub where you have all your agents, and then you have multiple MCP servers connecting to it. So what happens is, if you see the illustration, without MCP, you have several different LLMs, each bespokely speaking with all the external sources that you have. With MCP, you have similar to a single hub, and that can speak with all the different tools and external sources that you have. Next slide, please. So this is a breakdown of the MCP applications. So we have the MCP host, we have the MCP clients, and then MCP servers. Like I was telling before, today Google uniquely hosts 120 plus native MCP servers for connecting to various data sources. More are coming out as we speak, and then you can always build your own MCP server and provide a platform to host the MCP server. And then you can use it for interacting with all the different data sources that you have. We do have MCP server for Databricks, so you can seamlessly connect your agent to Databricks using the MCP server. Next, please. So that's all from my side. I'll just pass on to the excellent solution architects we have for the session. Thank you.
Awesome. Thanks, Samia and Brian. Really appreciate you being on. And now, folks, we're going to get started with our hands-on labs. I'm going to introduce Alexander Booth. He's a solution architect here at Databricks, and Kunal, who's a senior manager of field engineering here at Databricks. Mofid is also on the line. He's a champ. He is sick, but he is going to be here to answer Q&As in the chat. So thank you, Mofid, as well. And Alexander's taking on a second lab. So thank you to both of you. Next slide, please. This is also posted in the chat, but here are the access instructions for the lab. These were also shared via email, but now is a good time to get set up to make sure that you're good to go when you open them. And next one, please. Deployment instructions. I'm going to copy paste these into the chat as well so that you can set up your notebooks. And Alexander will let you take it away and share your screen to get started as people get set up. Thank you.
All right. Hello. Welcome. Good afternoon. Good morning. Thanks for tuning in from wherever in the world that you're watching this. Let me go ahead and share my screen and then we will get started here. Boom. There we go. So great to meet you all. Thanks for tuning in. As kind of Bonnie mentioned, my name is Alexander Booth. I'm a current solutions architect over at Databricks. I've been at Databricks for about 2 years now. Before Databricks, I actually worked in professional sports, specifically Major League Baseball. And so it's fun working on data on the Databricks side. I actually work with a lot of our sports customers over here too. But I have a fond spot for Google Cloud. Google Cloud is the official cloud sponsor of Major League Baseball. So they actually just rolled this out a couple months ago for opening day here in the United States, where they're actually incorporating Gemini into part of the game day app so we can get basically customized scouting insights from wherever you're digesting baseball. And this is all built, of course, kind of with AI, Google Cloud, and some of the MCP conversations that were happening right before this. So really interesting stuff here. And of course, if you want to get some more information on this, just look up Major League Baseball inside of Google Cloud's customers. So even from when I was a practitioner to what I do at Databricks right now, we support Databricks on top of Google Cloud, how we incorporate Gemini into our workflows and how we can still maximize the benefits of Spark for data engineering, as well as Unity Catalog for AI and machine learning governance on top of whatever cloud that you may be a part of. So yeah, I think that a few people are like, yeah, they had no idea that there was so much big data in professional baseball. All sports, whether it's baseball, basketball, cricket, soccer, National Football League, there's so much data happening in all of these areas right now. Essentially every pitch, every ball, every player, they're all being tracked at 30 frames a second up to 300 frames a second throughout the entire match. So being able to bring that data in and then process it real time during games and adding in an AI consumption layer on top for coaches and players is a really valuable potential use case. But while I could talk professional sports and Databricks and Google Cloud for the entire time, that is not why we are all here. We're going to be installing Databricks and playing around with our relatively new free edition version, which again is completely free to you. There's no charge. You'll be not asked for a credit card or anything at all. And this will give you a quick taste of what Databricks on top of Google Cloud looks like and what we're able to do. So I think Bonnie's dropped a link into chat already. Yep, we're going to be dropping in you're going to be going to databricks.com free edition /learn/free edition. I also just Google it sometimes, Databricks free edition, and it should pop up here. So it should just be the first one up at the top. Inside of Databricks free edition, we are going to sign up. So you're either going to sign up or log in, depending on if you've accessed the platform before. I'm going to be logging in with a Gmail account that I have set up. And you'll see that I've actually already been registered in Databricks free edition before, so I don't have to provide any information about myself. But as you all sign up for Databricks free edition here, you may not only just have to provide that email, but also some information about yourself. Again, you won't be asked for a credit card. You won't be asked for any method of payments. You should just be able to log in here. So this is what we're all doing right now. We're just logging into Databricks free edition. I would say if I could see you all to give me some thumbs up when you are seeing a screen that looks like this. But we'll give it a breather here on the homepage. I'll double check kind of the chats and the Q&A just to make sure that we're all able to log into free edition. We'll give it another minute or so here. So yeah, feel free to put something in the chat or the Q&A if you're able to log in. And then I know that we can get started here. When will beta features such as workflows be released? Yeah, great question. So a lot of things on the roadmap for Q2, including that will be released here in the next 6 weeks. In case you didn't know, the official Databricks conference, we call it Data and AI Summit, is coming up in about a month. So a lot of these beta features will be made available and announced going into Summit. All right, hopefully we've all logged in. We should see kind of this fun page right here. Notice we have some cool little nodes at the top, as well as some resources, suggestions, or how to start learning. We even have some basic courses that we could take. So if you really want to see how Databricks can be used for data engineering, our original bread and butter, we have some good courses for that you can take. Again, just built into the platform. I don't want to listen to that guy right now. Same thing with AI agents and AI patterns. So if you wanted to get some additional practice, our free edition not only is just a place to be hands-on, but does have built-in training concepts here too. I also like the product tours and demos. There's just so much new stuff that Databricks rolls out all the time that being able to keep up to date with all of everything here is really useful. If you lose the learning option on the homepage, it's actually going to be available here on the left-hand tool pane. So we'll be playing a lot with the left-hand tool pane today as we start installing our demos and running our code. So yeah, there's a few other things here. In our free edition, you do have full access to essentially all of Databricks. So you'll see here that we even have some of our beta features that I'll talk about a little bit later already available for you too. All right, so let's just get our hands dirty on the platform. We've already talked about the home page. You've already talked about the learn page. If we go into workspace, this is going to be our home, right? You're going to see that we have a user folder. So we can see that this is a folder. This is dedicated to me. This is my sandbox. I can create any files, folders, whatever really we need. It can all be created here in your personal workspace. So you can think of the workspace as your file explorer, your finder, your location where you'll be installing and creating and running a code. Also here on the left, we have a couple other options I want to hit on before we go to some of the fun stuff. If we click on catalog, catalog takes us to our data catalog. This is the single source of truth for all data stored within your Databricks workspace. And remember, Databricks sits on top of your cloud provider. So with Google Cloud, for example, all of our files that we create, all of our tables, they are actually sitting as Parquet files on top of your cloud storage, your Google Cloud storage on top of Google Cloud. And you can see here, I've been playing around with free edition with some of my baseball customers too. So kind of fun to, I told you I do this. I promise I know how to code in Databricks. So pretty cool stuff. Again, you shouldn't see too much. I think the only thing you'll be able to see in your data catalog right now is the workspace catalog with just the default database schema beneath it. with no tables or anything yet. But don't worry, we will soon populate our data catalog with all the tables you could ever want. Let's see here. Let's go down to compute. There's typically two types of compute that you'll play around with in Databricks. The first is what we call classic compute or serverless compute. Essentially, when we run code in a notebook, we want to make sure that we are executing our Spark workflows or distributed engineering workflows across a distributed cluster. That cluster can either live inside your cloud provider, such as on Google Cloud, or it can also live within the Databricks compute plane. So we'll get some examples of what that classic compute looks like when we jump into notebooks. The other type of compute that you'll run into on Databricks is going to be a SQL warehouse. The SQL warehouse operates as our warehousing engine. So it's optimized for SQL and specifically OLAP, analytical processing, big data cloud queries. So similar to any other cloud warehouse that you may be running with. So you'll notice in free edition, we actually don't give you the ability to create a SQL warehouse, and we only give you a tiny one. But whatever, it's free compute, so can't complain there. Yeah, we'll see that we'll be using some of our serverless SQL warehouses a little bit later on when we get into the SQL AI BI aspect of the lab today. Speaking of which, if we go into SQL here on the left-hand side, tab 2, we're just doing our introduction to the Databricks platform. You'll see in the SQL editor, this is where we can actually write queries. And again, you won't see anything right now because we have no data and we have nothing in our catalog. But if we did have tables, we could start writing queries here and connecting to our SQL warehouse to start executing queries. So again, don't worry, we'll do this in a minute after we've started adding some tables in. Let's jump down to the AI ML here. Well, actually, we'll go to data engineering next. Or maybe we'll wrap up on SQL. So on SQL, the other thing to call out, again, we'll show more of the SQL aspects of the platform later on in the lab today. But if we go into SQL alerts, this is actually pretty fun. Again, I'm a backend guy myself, so I like getting alerts when stuff breaks. We can actually add in alerts on top of that's running on SQL within our SQL warehouses on notifications from pipelines, notifications about the table itself, executions, job runs, or anything else that can be ingested through the Databricks API or SDK. So I think we'll be creating some queries and alerts a little bit later as well. And you're seeing the sneak preview of all of our AI tools and capabilities as well. The next section that we have in our tool pane on the left here is data engineering. Data engineering, I like showing the data ingestion. So we have a product that's called Lakeflow Connect. Essentially, all of our customers have so many disparate data sources floating around. And if we do want to create that single source of truth within the Databricks Unity catalog, we need to be able to quickly and easily connect to all of those different data sources. So a couple that I like to put out here, we have all of our classics, whether it's SQL Server, Workday, Salesforce, Confluence, SAP. Being able to ingest raw data from those SaaS providers has been a game changer. Some of the other ones here that are in preview, but again, with free edition, you still get access to all of our previews. We'll actually see that we have other warehouses such as BigQuery. So this is a common workflow that I have with a couple of my sports customers all built out on Google Cloud is how can we have Databricks and BigQuery kind of work in tangent to each other? How can we have them complement each other on their workflows? So BigQuery is a good use case for that. We can do this with Query Federation or just with Catalog Federation too. Sweet. So I think there's also a promotion going on where I think you get 100 gigabytes a day free or something of Lakeflow Connect. Sorry, tangent. I think this is a thing. Yeah, there we go. I'll say this is on the Microsoft side. I'm pretty sure this is also on Google as well. We actually offer 100 DBs per day of free Lakeflow Connect. So if you have any data, that's a lot of DB of Databricks, by the way. So if you have any data set that you want to start bringing into Databricks, you can probably do so now for free. So why not try out the BigQuery connector on your own time after the lab, after this. Why not, right? Free compute, always down for that. Finally, the last section that we'll see here at the bottom on the AI ML side is going to be our artificial intelligence, machine learning playground. There's a few things that I want to call out here. First, we'll start with models. When I click into models down here, this shows me our model registry. This is a core component of ML ops, machine learning operations, where we need to be able to manage the full life cycle of the model from experimentation and creation to deployment, serving, and inference. And it all hinges on the model registry. This is where we're able to train and register models that we want to be used in production. So you'll see here that we have quite a few large language models that have already been saved and deployed, and then one churn model that I created earlier before before this lecture. So we'll see here that we have a version of this model that's already been saved within our data catalog and data estate. I like using the models. We can tag, add comments, add descriptions, add teams. Basically, you can see what models has your accounting team made, what models has your R&D team made, what models has your finance team made. Pretty good way to organize and govern the various classical machine learning as well as large language models or agents as well that your organization is creating. Supplementing the model registry is going to be experiments. Experiments is, of course, where we try different creations of building models. So you'll see here I have a few that I've done over the last 6 months or so. And I think this is the one that I did today while we were testing this out. Basically creating our churn model. We can see that we try various different algorithms. We can tune different hyperparameters. If you're doing a grid search, every grid search iteration can be saved here as an experiment. And we're able to then have the full reproducible stack, right? A common question that I get with machine learning is how do we make it more so like the scientific method? How do we make sure that we're able to fully reproduce, we're able to fully test and iterate on various versions of the model? And having a good MLOps framework, which Databricks supports using the open source library MLflow, is a great way to do that. Once you have a model, we host the model, serve the model. That's what a serving endpoint is. Essentially, this can be any model trained on Databricks or even a gateway for any external models. We can containerize, put into Docker, and then host for you using our serverless compute, the model for fast inference. We touched on Gateway there, so it is worth calling out our new AI Gateway product. So this actually, we're calling it Unity AI Gateway. This is version 2 of our Gateway product, and this will be announced keynote in June on our conference. But like I said, free edition gets all the good stuff. It gets all the stuff that we're doing in production anyway. So again, you can play around with our newest features for free here in free edition. What does Unity AI Gateway do? It creates a pass-through gateway to any machine learning model, large language model, or agent that you may see downstream. What this allows us to do is to track usage, to track auditability, monitor usage, monitor cost, monitor inference, as well as configure rate limits and guardrails. So some of the MCP conversation we talked about earlier at the start, I have plenty of customers that route to their MCPs through our gateway product. Again, the endpoints don't have to live inside of Databricks. They can live anywhere. They can live in Vertex. They can live on Google Cloud. We're simply going to be a wrapper for this. Other use cases for this too, I have plenty of customers using Claude Code, Claude Cowork, Claude Desktop, but maybe you have your own Anthropic subscription. You can still route the requests that those applications make to Anthropic through our LLM gateway, which allows you to have full governance. So you can make sure that nobody's asking your Claude Code, instructions on how to make an apple pie. When they should be obviously optimizing linked list chains or something, right? So again, you can add in guardrails around what people are talking about, PII or other types of information. So let's see all this cool stuff in action. If I click on Playground, this will actually take me to a chat interface where we can play around with different agents as well as large language models that may have been deployed into production. So up here at the top, you'll see that I'm using the GPT open source 120B by default. And I guess this is one thing that Free Edition doesn't have. Free Edition doesn't have all of our proprietary kind of model I guess, partnerships that we have. So, for example, we are heavily partnered with the Google Cloud, which means that we host Gemini natively within Databricks in our Enterprise edition, not in Free Edition. It looks like in Free Edition, we only have our open source models here. So they're all pretty good. Let's stick with GPT open source 120B. You'll see that this is routed through the AI gateway as an endpoint. So anything we do talk to this model about will be tracked for full auditability usage. So let's actually just say something, maybe write me a haiku about Databricks. And Google. We'll slap in a Google Cloud there as well. Databricks hums bright on Google Cloud's vast blue sky. Data streams converge. Snaps. That was beautiful. What a great haiku that we got there. Notice in Playground, we can also add in like comparisons. So let's switch the model. Let's maybe go to, so all I did there, by the way, for folks following along, I clicked on this little plus icon, which was added an endpoint. So that's how I got a second LLM next to us. So I want to switch over to Maverick. And I'm going to actually ask it to do the exact same thing. And you'll see that one of the fun aspects of the Playground is that we got the sync in action here. So we'll be able to see time to first token as well as the response that it generates. So I think this one was a little bit faster. Yeah, 24 tokens a second, 1 second a first token. This one was 202 tokens a second. So I don't know. I kind of like the 120B version. Spark clusters ablaze, Google Cloud's vast storage feeds, data's sweet delight. Yeah, I like the first one. But again, this allows us to like compare, test out different LLMs. And what I have plenty of customers doing, if they have multiple versions of an agent, they're able to test them both here with real human users before moving one into production. But I'm getting ahead of myself. We're not here to play around with open source LLMs. We're here to deploy and run workloads on top of Databricks. So I'll take a quick breath here before we get moving to installing our demos. Let me check out the Q&A, make sure there's nothing crazy. Yeah, the DB demos model, that's good. Yeah, under your model section, the only thing you should be able to see would be any of the default system models here. So maybe you have something defaulted with this owned by me. Just make sure that all that's turned off. You should all be admins in your own Free Edition workflow. So you're able to see kind of these default. Really what I care about is if you go to the Playground, are you able to interact with the Playground? And you should be able to have some default LLMs already up here. As we move through the labs later over the course of the morning, we will have models generated that should also show up in the MLOps section. Good questions. All right, let's get after it. That was my 20-minute introduction. All right, let's go into Workspace. What we're going to be doing here today, we're going to be installing one of our Databricks demos. So this is another link that hopefully Bonnie can throw into the chat for me. It's going to be dbdemos.ai. So, and that's going to route us here. I remember back when, I feel like we got that .ai domain for cheap. I don't know if y'all have seen this. It's like so many companies now are trying to register .ai domains, and I think it's tied to like an island chain in the Caribbean that they're able to like generate a lot of money off of this. Yeah, there you go. This was announced like last year. Anguilla. God, I shouldn't have tried to pronounce anything. But yeah, basically, if you want a .ai domain, it's going to cost you a lot of money right now. Reminds me of like .tv was Tuvalu. So when Twitch was a big thing, or still is a big thing, any of those .tv domains have to go through the Tuvalu island. So anyway, a little fun fact. I'm pretty sure that our dbdemos.ai, I don't know how much we pay for that .ai domain. But either way, it should route to our tutorials demos here. So we're going to be installing one of these demos and then running through the notebooks together. So let's get after it. In our home page, let's navigate to our workspace, which is going to take us to our user folder. Inside of our user folder, we're going to be creating a notebook. Create. I'm going to click this big blue button here at the top right. We're going to go to create notebook. Note we could also create folders if we wanted to organize things, as well as clone repositories down from GitHub as well. We're just going to create a base notebook here. That should open up our notebook editor, which should look something like this. In our notebook editor, we have a few different options. I have my left-hand tool pane where I can see these little three shapes mean catalog. I can see my data catalog here on the left. Or if I click in a folder, it'll show me my workspace folder if I have other notebooks or other folders that I want to show here. On the right-hand pane, we're going to see that we have a bunch of options if we wanted to interact with our machine learning experiments, or if we wanted to interact with our underlying cluster configuration and compute environment as well. What we're going to do though is we're actually going to play with our top toolbar. With our top toolbar, you'll see that we have a default language. On my screen, it's either Python or SQL. And then over here on the right, we have different options such as getting our file, edit, view, run. I got that from the 3 dots. We have a play button to run the notebook. And then we have this little green circle. This green circle is going to allow us to attach to a compute instance. And this is what I was talking about at the start of the lecture. You'll see that part of I have two options here for compute, right? I have my classic or my serverless compute, which is great for just running regular Python, regular PySpark commands. And then I have my serverless warehouse, which can only handle SQL. So a good thing to remember, classic compute, serverless compute can handle any language, Python, R, Scala, Spark. And serverless warehouses only handle SQL warehousing commands. So maybe this is good if you have a bunch of stored procedures in your transformation layer. You can optimize the performance of those procedures using just a SQL warehouse versus serverless. But either way, we should have a closed green dot. I want you to click on serverless, not SQL. We're going to be writing code in Python. So we're going to be clicking on serverless to make sure we are able to write. And we should have a closed green dot here. Now you have a couple of options in the Zoom chat. Bonnie's already added in the code that we need. So you can either rip it from there or you can rip it from the tutorial instructions. The tutorial that we're going to be using today is going to be, I'm going to go to tutorials, I'm going to go to explore all, and then we're going to be clicking on this first one here, just reducing customer churn within the Lakehouse platform. So our goal in this demo is to basically build a solution, build a customer 360 solution, and be able to also integrate machine learning models to predict the likelihood of customers churning. So you'll see we have some instructions there as well. I'm going to take it from Bonnie's instructions in the chat because I think that they're better because I wrote them. And there's one quick change that I want us to make to the actual installation. Otherwise, it won't work. So let's rip this from chat. I'm going to grab the first cell, which is just going to say pip install Databricks demos. I guess I have to type it out myself. Pip install DB demos. And then notice that I added a % here. That % tells the notebook to run this code as a terminal command or as a command line install. So this is going to be installing the DB demos pip library into our serverless compute. To execute the cell, I did Shift Enter on my computer, or you can run the play button or click the play big blue button there next to the top of the notebook. All right, the second command that we're going to be typing in, again, I'm going to take this from the chat as well. We're going to restart Python with that dbutils.library.restart Python command. Oh, there we go. Now I'm able to copy from the Zoom chat. So this is just going to refresh our serverless environment to utilize the new libraries that we've installed. And now we can do the fun stuff, which is actually installing the demo. So I'm going to copy again from the Zoom chat. And we're going to paste this in here. So let's run through what this cell does, because this is where there's a couple of changes. The first thing that you'll see is that we're importing the DB demos library, and then we're installing the demo. We give it the title of the demo that we want to install. I just took that from the documentation, right? But then comes the changes. Instead of running this in my main catalog, we don't have a main catalog. We only have a workspace catalog. So within the workspace catalog, we want to install the demo. For the demo schema is just going to be the 361. And then I also recommend adding in the overwrite equals true. This just refreshes the content if you run this cell more than one time. So the biggest change is to make sure you change the catalog to point at workspace instead of main to get this to work in free edition. Behind the scenes here, this is going to be installing multiple notebooks as well as jobs that should run in the background for us as we start reviewing the content. So it looked like that worked, and it even gave us the GitHub link. This is all open source, all of these demos. Feel free to follow up with any of this content on your own time after the session today. Cool. It even gives us all the list of all the notebooks that's installed, the pipelines, the dashboards, and all of the jobs too. So looking really sharp here. To make sure that this is actually showing up, if you click into the workspace icon here on the left, you should hopefully see a new option for this Lakehouse Retail C360 folder. So if this is installed correctly, you should see this new folder pop up that says Lakehouse Retail C360. Cool. Take a breath here just to make sure that we're all doing the same thing. Again, all we're doing is we created a new notebook and we pip installed our demo, and then we loaded in our demo into our free edition workspace. If you want to save this notebook forever, you can click on the tab name up here, and we can actually rename this notebook. We can just call it like install Databricks demos or whatever, or something. You can name it whatever you want, right? This is a title. And if you did have GitHub synced up with Databricks, then everything is completely source controlled as well. We can commit changes from our notebooks and scripts back up into GitHub. Cool. All right. So if this is all worked out, let me do a quick peep in the Q&A. Oh, look at that. Q&A is quiet. There we go. Good job, class. You're all doing so well following along. All right, let's jump into our first notebook. So again, what I'm doing here is I'm on the left-hand toolbar, clicking on the workspace folder. I'm going to click on the folder that we installed, this Lakehouse Retail C360 folder, and we should go down to the 00, this churn introduction notebook. If I click on that, it should open up here on the left-hand tool pane. And this full notebook, it's not actually anything to run. It's just going to give us some instructions just to get our feet under us of what we're going to be doing here for the next couple of hours. I think you have me for another hour or so. Yeah. I was like, could all let me know if I'm also crazy on times. I think we should be good though. All right. Let me close this. Just if you want to free up some space on the left-hand side, I'm just going to click on that X. We can always bring it back by clicking on the icons. All right, so our goal here, our goal is to utilize Databricks to maximize information about our customer 360 as well as reduce customer churn. So we're going to be unifying, we're going to be role-playing as John first as our data engineer. We're going to be unifying data from many disparate sources, maybe coming from CRMs, web analytics, mobile apps. We're going to be building that unified customer 360 integration inside of Databricks. So establishing that solid data foundation, walking through the medallion architecture, how we move data from raw to clean to actually ready for consumption. Next, we're going to roleplay as Emily, who is going to be our governance and security engineer. We're going to run through a couple of examples about using role-based access controls while also maintaining lineage and observability for compliance protocols. Then we're going to move into our data scientist and data analyst roles. We'll be working as Mark to create a machine learning model to actually predict churn. as well as working as Alice, our BI analyst, to utilize SQL analytics, basically using dashboards, Genie, conversational AI to be able to drive strategic decision making. Again, this is what I mean about the consumption layer. How do we go from raw data to insights? As much as I love the back end, I say like we never just make data pipelines in a vacuum. The whole point of bringing data in, the whole point of using Databricks and Google Cloud together, create that holistic single source of truth to power strategic decision making, specifically data-driven decision making downstream. We'll be incorporating what Lisa is doing. Lisa is doing with generative AI as well, as both Alice and Mark will be implementing large language models throughout the entire demo today as well. All right, so we're going to start with data engineering. Our first step is to take the raw data that we've received and ingest it through the Databricks platform. Typically, when we start ingesting Databricks or ingesting data, we split it up into this extract, transform, load data pipeline paradigm, where first we need to extract data from source. We talked through this originally when I showed the different parts of the platform, but Lakeflow Connect handles that first part for us. How do we extract data from various different data sources and bring it in a raw format into Databricks? While this can be done with a plug-and-play connector like Lakeflow Connect, this can also be done with APIs or other connections to FTPs or even web scraping. Again, at the end of the day, it's just files that live in your cloud storage that Databricks can at least read. So that's all that we need to do. Once we have the raw data available in Databricks, Databricks recommends utilizing Spark declarative pipelines, which is another open source tool to quickly define data pipelines at scale with expectations and data quality checks included that can handle both batch and streaming workflows. Spark declarative pipelines is a data engineering framework. What I mean by that is, of course, you can still write your own data engineering transformations as independent queries or scripts. Take data, clean it up, drop your duplicates, change your data types, and now it's ready for aggregation. But with a framework, this creates a reproducible and consistent way of managing data pipelines. All data pipelines through your enterprise will be structured in the same way so that it's easier for support and AI tools to both debug as well as iterate on quickly. Right? How do we reduce operational complexity in your data pipelines so that you can focus more so on the data decision-making capabilities of those data sets? We'll breeze through here for the rest of our introduction, and then we'll start writing some of our code. Next, on the data governance piece, we're going to showcase how Unity Catalog does provide those audit logs, accessibility logs, and data lineage, as well as integrating with external data shares so that anybody even outside of Databricks can utilize and query the data for analytics. On the SQL AI side, Databricks does have native dashboarding capabilities, so we will show that, as well as our text to SQL, as well as agentic AI decision-making prowess. How do business users that are logging into Databricks, how can we make sure that they only see relevant information to them, as well as are not overwhelmed by the complexity that data engineering can have on people? Finally, as the data scientist, again, we're going to walk through the full ML lifecycle, how we can experiment on a model, save a model to the registry, serve a model onto an endpoint, and then use that model for inference and predictions. And again, we have low-code solutions utilizing our Databricks Genie assistants as well as AutoML capabilities. Cool. We're going to then make this a full workflow as well. While Databricks can supplement many existing data systems, it can also holistically run as its own single suite of data products, as we'll showcase today. All right, so let's pivot into our first content here on the data ingestion side. So before we open up any notebooks, let's take a quick look at the data that we're going to be ingesting. So I'm going to open our data catalog in a new tab, but feel free to interact with it in the same tab that you're currently in. So to open in a new tab, I'm going to right click on catalog here in the left-hand tool pane, and then click on open in new tab. And this takes me to our data catalog. And if all goes well, we should have, we should have a new database inside of our workspace catalog. We should all see this DB Demos Retail C360 database now, if we installed things correctly. And we see that we have a model, we have 7 tables as well as a volume. So I'm going to go into the volume here. This is where our raw data is going to sit. So I'm going to click on this C360 folder. And you see its little folder with a cloud icon. All that means is that this is a cloud storage bucket somewhere in the world. So on Google, this would literally just be a Google Cloud storage bucket that we've allowed access Databricks to read and write to. So what I wanted to show here inside this cloud bucket, again, if you logged into the Google Cloud UI, you can navigate there, see these files there as well. This is where our raw data has landed. So you can pretend that we already had maybe a Lakeflow connector or some API requesting notebook where we went off into the internet and we went and fetched data. So if I look at the users folder, you'll see that we have all of these, I think these are Parquet files. I'm not sure what they are. Let me click on the first one. I think these are all Parquet files. Yeah, there we go. Or JSON or something. Whatever this raw data is that's come down, we can see that it is semi-structured, right? We have dictionaries of all of my users located here. So we have their ID, their first name, last name, email, age, as well as our machine learning feature, whether or not they've churned. This is, of course, fake data, but I wanted to showcase that here we have semi-structured data. Let's click on one of the other ones. Let's go to events. And let's open one of these ones. This is also, this one is like a CSV. So this is a comma separated value flat file. So we can see in this table here, we have a flat table of our user, event, platform, date, action, and URL. So we have a flat file here as a second data source. Again, maybe this is coming from the mobile app or Salesforce or something. And then what's the last one? Orders. Yeah, this is also semi-structured data. So we have these dictionaries of key value pairs that have come back as well. So our goal is to ingest each of these 3 data sources, the events table, the orders table, the users table. We want to ingest these raw sources into a standardized data set, specifically a medallion architecture in Databricks. So that's our goal. So now that we know our goal, let's go back to our notebook and let's start looking at some of our pipelines here. I'm going to open up the first one, which is 0.1.1, our Spark declarative pipelines in SQL. Just for a fun fact, these 2 folders are exactly the same logic, just written in 2 different languages. This first one allows us to create this data engineering pipeline exclusively in Spark SQL, which just uses regular SQL syntax that then gets compiled as Spark on the query engine. The second one uses Python and PySpark to do the data transformations, which again, at the end of the day, still gets compiled down as Spark downstream, but is obviously a different syntax, and PySpark does have a little bit of a learning curve in developing it. So I'm going to open up the first folder here, the 0.1.1 churn SQL folder or file. And again, note that we're not actually going to run this notebook either. This is just going to be more of a descriptive notebook as well for what we're going to be doing. I promise you that we'll look at some code here in a sec. So what we're going to be doing, like I mentioned, we're going to be role-playing as John. We have multiple data sources that we want to ingest, as we've already shown. And we want to bring in those data sources from blob storage to create multiple different tables, customers, orders, and events, and then unify them downstream. So what we're going to be doing, we're going to be building a declarative pipeline. And again, you can see that we're bringing our app events from Google, our ERP orders from SQL Server, our user information from Salesforce. We've shown how those have landed. We're then going to be constructing this medallion architecture. So I'm going to get my little pen out. So what I wanted to kind of show as we work through data, the paradigm that Databricks champions is having your raw data be replicated into a bronze layer That's what this is right here. This looks like exactly what our cloud storage bucket looks like. This is the dirtiest of data. It's only supposed to be only supposed to be representative of what came from your data provider. Then we start cleaning up our data as we move downstream. So we have two silver tables here, churn orders and churn users. You can think of this as applying schema enforcement, applying data type enforcement, applying primary and foreign key constraints, adding in drop duplicates, all of that good stuff. One thing to notice is that this is a paradigm, and of course, it's flexible. So the app events, for example, this is the flat file, the CSV that we saw. This data is already clean. So its bronze version doesn't really need a silver. So this is essentially coming in as a silver table. Once we have our clean sources, and again, you can see we have a bronze, silver for each of our individual data sets. Now we want to actually join this information together to make it useful for AI as well as machine learning modeling. So we're going to create this churn features table where we join together all of our clean silver level tables, your reporting, your staging level tables, to create these reporting level aggregates. Then we're going to train a model here in the middle and then generate predictions down at the end. But for right now, we only care about this half of the data pipeline. How do we go from raw data to clean data to aggregated reporting level data? And again, Databricks calls this bronze, silver, gold. You've probably also seen this as like raw staging reporting. I've also had a few customers that use different metals. So I've had like amethyst layers, platinum, titanium. I'm like, whatever precious metal or whatever you want to name your architecture is fine by me. But specifically, we want to have good observability into what data is being cleaned, how it's being cleaned, and how we can support it. Let's see, we've already talked about our bronze layer. One thing to call out on the bronze layer is that not only do we allow for batch inference, where we incrementally load files from cloud storage, we can also make that live. We can ingest directly from streams such as Kafka, Kinesis, what have you, as well as even stream in from cloud storage. We fully support things like file triggers. So as soon as new files land, that actually triggers the ingestion job itself, or we can have compute that's always on and listening to the bucket. Just define your folder and Databricks take care of it. It's usually that easy, but I will say, I won't always promise that Databricks will just take care of everything. Cool. So let's go ahead and look at how our bronze layer is being defined. We're going to go look at the first stage of our pipeline here, which is the 01 bronze SQL. You can either click this link on our notebook, or if we go back into our workspace, we're simply going to go into transformations, then open up 01bronze.sql. And again, note that we're not running this. We're creating this code so that it can orchestrate itself as part of a pipeline. So notice that we're not running anything here. I'll walk you through how this creates the pipeline here in a second. But there's a few things that I wanted to call out in the definitions of our bronze tables. So notice we have 3 definitions here, one for each of our 3 data streams, right? We're defining a bronze table for our app events. We got another one for the orders and one for our users. So let's look at the first one, which is the app events. This is coming from a CSV. So it's already pretty defined in its schema, right? It's a small data set, flat files, and this is how we're ingesting it, right? Select star from cloud files, and this is the location of the raw data set. We typically just give it the file type, and then notice that I'm having it infer the data types as we go. So this is one option. Note that depending on your data sets, inferring the column types may be slow or may be untrustworthy. I have plenty of customers that ingest things as like raw strings in bronze and then do the data type definitions as a silver level enforcement. Whatever floats your boat. I don't really care either way. The other important thing to notice here is this cloud files function. You're going to see this used in the definition of all of my bronze tables. This allows us to do that incremental data ingestion. We essentially have checkpoints that are created behind the scenes that look at what files we've already ingested from the cloud storage buckets. Two more things to call out here for my tables, or I guess three more things. Second, let's talk about the comments. We're going to talk a lot about in the second half of the lecture the idea of making this AI powered and AI ready. The best way to do that is by adding in a semantic layer. So semantic layer is just going to be the business descriptions, the business level options, essentially what is this data, right? What is the data? What is the tables? What's the columns? What's the point of it? What's the use of it? If you just ask AI to go and look for something in your database, it'll be able to find it better if it is descriptive, if it's got descriptions and semantics already defined on what it's trying to look up. Again, at the end of the day, we want to really, really minimize the likelihood of these LLMs hallucinating and making up information. And especially if everything is living as a single source of truth in your data platform, like Databricks with Google Cloud, it should be descriptive enough that the AI knows what it's looking at and should be able to return those results back to you. So highly recommend adding in semantic context such as comments and descriptions at the table and column level. Two more things to call out. The first, I guess we're going bottoms up. Let's look at the expectations. We talked a little bit about this at the top. Expectations allow for data quality enforcements. In Spark Declarative Pipelines, which is that framework for defining your bronze, silver, gold layers, we allow for built-in constraints and expectations. No need for third parties or open source requirements, and no need to have separate queries that look for null values and quarantines them, or looks for outliers and quarantines them. Again, there's are ways to do that in regular Python or regular Spark, but especially with declarative pipelines, we can have those expectations built in. So you're going to see here that all three of these tables are expecting this rescue data column to be null. Essentially, what that means is that rescue data tracks change data capture, it tracks schema evolution. As new columns are added to the data sets, if they're not officially expected in the schema definition of the table, they just fall into this rescued data bucket. So we are expecting that there's no odd data sets or no odd rows with new columns across all of our sources here. Notice you can also have expectations for primary keys to be not null or data to be less than a specific value or something like that as well. Finally, you're going to notice that all of these are streaming tables. While this job is going to be running in batch mode, Databricks and Spark itself as a technology always kind of started from streaming. If you think about it, it's kind of a really weird little thought exercise. But if you think about it, a batch workflow that just runs every day at 2 in the morning, that's essentially just a really slow stream, right? And I would challenge you that if your batch workload is just running once an hour, that's still just like a really slow stream, right? Where data is only streaming in every hour, right? Not just every second. So if you think about data pipelines from the paradigm of supporting streaming workflows, batch just becomes an easier add-on as it's just a really slow stream, and we can turn off the compute in between triggers. So we're going to have these defined as streaming tables, which just allows for some Spark optimizations behind the scenes in terms of how the pipeline is created, as well as how we checkpoint new rows as they flow through the full data lineage. Let's get to the fun stuff. Now that we've defined the data ingestion, we want to define the data transformations. And this is where the fun begins. Churn orders and churn users, this will enforce the data quality. Again, we've already talked about how the app events is already a good quality and doesn't really need its own separate silver staging. In fact, we can just fast forward it into silver. But the orders and users we do need to clean up, especially since they are semi-structured data sets. Especially in my work, I see a lot of that data type are read in as JSON or variant, and we need to explicitly define flat schemas in the silver layer to allow for aggregations and joins in the gold layer. So let's take a look at what our silver definitions are. Again, same idea. We're going to go open up this 02silver.sql. And again, we're not running anything. We're going to orchestrate these files as a job, essentially. And the astute among you may already have noticed that these are flat files. These aren't notebooks. It doesn't matter if you use flat files or notebooks. Databricks fully supports both. And I have plenty of data engineering purists that I work with that only want to bundle up flat files. There's also some settings you can make in your Databricks profile where everything can just default to a flat file if you want as well. I like flat files as well, mostly because when I bundle up and deploy, I'm able to incorporate unit tests and integration tests, which are also fully supported with Databricks too. All right, so let's look at our transformations here. This is the fun stuff. So let's look at our first one. The first thing we're going to do is create a silver cleaned version of our user table. And there's a few things that I want to do here. I want to make sure that we anonymize and hash. We incorporate PII correctly. I want to make sure we clean up data formats as well as clean up our column names. So typical silver level transformations for a raw data source. So again, let's work bottoms up here. I'm going to work with my query. So this query is just going to be the definition of my silver table. You can see that I am selecting different options from my bronze table, which again, since it's a stream, we're only going to be looking at new rows every time this pipeline runs. So we're going to be grabbing new rows from the bronze table, formatting them like this query expects, and then shoving those cleaned rows into our silver table. So you'll see here that we do a few things, like we're hashing the email to make sure that it is private and hidden. We're fixing the data types for our dates just to make sure that they match our date time expectations. We're fixing the capitalization of a few of our columns, as well as fixing our data types as integer for a few of our columns here too. Notice that we also install a couple of other options. So again, we have our comments for discoverability. We also have some Spark optimizations. There's a lot that Databricks does to auto-optimize your tables, and part of that can just be partitioning, optimizing the data layout for large-scale OLAP queries. Z-ordering, we don't need to... Ask the chat, ask the Q&A to explain Z ordering, and we'll put the TAs to work because we'll see how quickly they can get a definition for what is a Z order. But essentially, this will make sure that we partition our table in an optimized way. Kind of, again, we're grouping optimizing by our user ID here. And then finally, we have a expectation, which I love as a data quality guy. So notice that we have a new expectation where the user ID from the bronze table cannot be null. And if it is null, we drop the row. So this automatically quarantines and separates out bad rows as they come into silver. And this gives me, I can sleep easier at night knowing that my silver tables will never have a user that's not null. And again, this can operate as a primary key in my downstream star schema if that's how I wanted to design my gold tables. A similar idea for the churn or for the orders table. We're streaming in from the bronze table, only pulling in new rows. We're fixing our date times, and we have expectations around primary and foreign keys here. So my order ID cannot be null from the bronze table. That will be my primary key here. And user ID, which is going to be essentially acting as a foreign key to my user table, that cannot be null either. And on violation, we're dropping both rows. Note that you can also quarantine these out to separate tables if you want to keep them and look at them later. And again, all of this is fully logged in our audit tables, so you can track which rows are dropped or not. We'll fly through the last little bit here, which is going to be the definition of the gold table. So our gold layer, this is where we start joining up our disparate data sources together, creating aggregate level feature tables to power machine learning workloads, as well as to power in our dashboards or external looker on Google Cloud. There we go. Or if you wanted to push back to BigQuery, I have some customers doing that as well. So a lot of different options for what to do with your gold tables. But again, this is essentially what the analysts are going to want to be looking and using. So let's take a look at what our gold definition is here. I guess that opens up in a new tab. Let me open it up here in the same tab. So our gold level table here. Notice all that we're doing in this table, there's a few things that I want to call out. The first is that we're creating a materialized view So this isn't a full table, but it's a materialized view, which means it refreshes from its silver level tables, but it's also saved off inside of your cloud storage still as well. So this removes any potential governance issues of gold level analysts interacting or deleting underlying good data from the silver layer. So again, materialized views or just regular views are pretty common gold level table objects. I also see them as regular tables as well. It doesn't really matter to me either. Make sure you have our comments, and then we're going to see our queries. Again, what I wanted to show is that we're joining all three of our silver level tables together. We're pulling from our two silver tables as well as our user table and your users, app events, and orders. We're going to be aggregating and joining everything based on our full fan 360. So you'll see that we're grouping by our user and we're joining on user. And if all goes well, we should have one row per user that contains a lot of good information, such as their order counts, event counts, and days since last creation or activity. These are all going to be features that we can then use to help predict if a customer is going to churn or not. The second table that we're going to create here is our inference table. It's going to be our materialized view of the predictions. So what we actually have is we're going to end up with a user with a Spark UDF, a defined function that is going to take the input features, run them through our machine learning model, and save that inference off as churn predictions. This will allow us to have a new column that contains our prediction as well as whether or not the customer actually churned. Again, a couple different ways to architect this. I sometimes see customers having their inference tables just as a separate, almost like silver plus level table, and then joining those inferences downstream into gold as needed. So again, that inference can happen honestly wherever you want it. I probably see it more often happening between silver and gold than directly in the gold layer itself. But for the case of this demo, it doesn't really matter. And again, if you're curious about what this user-defined function looks like, if we look at the 04 file here, this is what it actually looks like. So you're going to see here that we are going to be grabbing our machine learning model, right? We have the virtual environment based on the requirements needed for that machine learning model, and we've registered a custom function called predict churn that is just going to basically handle the inference using our MLflow package manager behind the scenes. So it's this predict churn function that's used in this predict churn function here in the SQL definitions. So we should have reviewed all of the notebooks. So let's go look and see what this looks like as a pipeline. I'm going to do a quick look at the Q&A. Yeah, everything will be recorded. Yeah, and all of this stuff is available in GitHub. And yeah, it's also just a public demo, so you'll be able to definitely look at that. Shravan's asking about how does it only take new records from a bronze table? Yeah, great question. So if we take a look at kind of what we were talking about, and let me grab it, the kind of SQL here. Essentially, when we define a table as a streaming table, which what we're looking at here in number one, we're defining our bronze table as streaming tables. Behind the scenes, Spark is assuming that this table is typically going to be an append-only table. We're only adding new rows, right? When we think of streams, we think of constantly pushing information out that just gets added on and appended to different tables. So when Spark SQL and Databricks is then ingesting from a table as a stream, I mentioned earlier that it keeps checkpoints of files that have been processed. With Databricks tables are stored as files. They're called delta tables or iceberg tables, which are essentially stored as Parquet files behind the scenes on your cloud provider. So just like ingesting from a cloud bucket of a JSON object, when Databricks looks at its streaming table, it's looking at the file partitions behind the scenes and only looking for new partitions that haven't been processed yet. So this allows Spark to see only new rows or new files as part of the underlying bronze table, and then see that it's not in the checkpoint. They need to be ingested and processed and then appended to our silver tables here. So in this specific pipeline, it's pretty simplistic in that everything is an append only. In the real world, you would obviously have a lot more like merge upserts as part of your streaming logic, and that can definitely be done and can definitely be optimized for performance, but is out of scope for today's conversation. But yeah, long story short, because we're using this framework of streaming tables with checkpoints, that's how Databricks is able and Spark is able to only look at new rows. Yeah, good question. All right, so let's go look at our full pipeline here. To go look at our pipeline, all that I'm going to do is I'm going to open up jobs and pipelines in a new tab. And again, you may have seen that these have been running as background jobs. And yeah, there's actually a little bit of a typo in one of them right now, which is why they basically just run forever. But let's take a quick look at our pipeline. I wanted to showcase what it looked like. It looks like this one actually ran with a success. Very cool. Let me see if this, oh my God, this did actually work. Sweet. So let me kind of walk through how I got there so we know kind of what's happening and where things are going. Oh yeah, let's go. Look at that. That's all running as well. If you're wondering why I was talking so much, it's because I knew these background jobs run forever. So let's say that we have all of these notebooks or transformation scripts and we want to compile them into a job. Databricks has some interesting terminology between jobs and pipelines. Essentially, a pipeline is going to be our Spark declarative pipeline, where we're using this progressive framework of having expectations and kind of movement between tables, as well as just regular orchestration jobs, which allows us to orchestrate notebooks or flat files together in a single way. So first, if I click on pipelines here, you'll see our declarative pipeline that was created for us in the background. So mine is this first option up here at the top. While we can click on that, if I also go to create, this will show you how to create one of these pipelines. So if I go to create, let's click on the second one here. Ingestion pipeline, that's our Lakeflow Connect, like I said, basically pulling data in from sources. But ETL pipeline will be specifically for Spark declarative pipelines. We're not actually going to build this or submit this, but I'll show you how it works as an example. We're just going to call this SDP test. Notice that we have a couple options here. We have triggered mode, which is batch or file trigger, or continuous, where we're always listening for new pushes from the source. We can add in governance around usage and compute policies. And then this is the big one, right? We want to look for the notebook or folder that contains all the pipeline code. In our case here, that is going to be our transforms folder. So again, you don't have to follow along with this. I'm just demonstrating what it's look like to create a declarative pipeline folder. So in our case, I'm going to use this transformation. Hold on, source code. I thought it was just going to be, yeah, I think it's just going to be kind of that first. Yeah, we're going to be adding in all of the different code here. So I'm adding in our bronze. I'm going to add in our silver. And we'll add in our, whoops, gold. So we're adding just all the files needed for our pipeline. And then Databricks, because it knows the paradigm of the framework here, it's going to be able to understand exactly what all of the table dependencies actually look like. We can save this off inside of our workspace to a new, to wherever we want to load it. I'm going to say it's going to be going to the default schema or whatever new schema we want, and then create the pipeline. So again, notice this is all based on the flat files of our streaming table dependencies. So let's look at one that's created for us. Again, how I got here, we clicked on jobs and pipelines. I clicked on pipelines, and it should have hopefully one of these that say DB demos. And if it has a green check mark, great. If it doesn't, don't worry too much about it. Mine was failing before the lecture started today. So let's click open this pipeline, and this is kind of what I wanted to show. Look at this. Isn't this magical? Let me move and get this out the way. So again, if I just go to settings, you'll see that's the exact same routage that I showed earlier. And note that in this case, we're actually loading up all the files using the star asterisk in terms of the pipeline. But let's look at what I was showing. When we load in these files, because it's a declarative framework, Databricks and Spark automatically are able to track the lineage of how we're defining these tables. What's a streaming table? What's a materialized view? What's just a regular table as needed? So we can see the dependencies. We're loading in these 3 tables. Then we are streaming to create our silver versions of orders and users. All 3 of those tables go into churn features, which then creates our churn predictions table. When this pipeline runs, this pipeline can run on a schedule, and it can also work as a full refresh, which will completely refresh and truncate the whole table schema, or we can just run it through the existing tables. This validate option is also good. I'm not going to click this now because I'm already a little bit behind time. But validate allows us to make sure that the pipeline could work based on the schema definitions and that we have no typos. Again, one thing you may have noticed is as we were building out these flat files, because we weren't running the code, it was hard to debug or check to see if any of our code is actually going to work. So the validate option in declarative pipelines allows you to do that. Note that we fully support partial failures for partial refreshes on what we want to refresh. And we can see that my whole pipeline ran in about 7 minutes, which is pretty good for this pipeline, honestly. Cool. You can see that it was failing a lot earlier. I'm not sure what happened to fix my MLflow server, but we'll just go with it. So yay, we got all green, which is awesome. So how does this pipeline fit into the wider orchestration? As we talked about, the other way of creating and orchestrating options within Databricks is with jobs. Jobs allow us to orchestrate not just pipelines, but just flat files, notebooks, queries, alerts, what have you. Also just any other type of downstream requests if you want to refresh an extract in Tableau or something, or Looker. This is a great way to do that as well. So you'll see here that my model is still running, trying to figure out how to register this model into, it did register. Now it's running the inference. Cool. So we're almost done on my job. But to create the job, essentially all that we do is we click this blue button for create. And if I click on a job, this gives me a much more classic Lakeflow job interface where we can add in different tasks, whether that task is ingesting from Workday, whether it's running a notebook, whether it's running a visual data prep. Oh yeah, fun fact, Databricks has a low-code data engineering option now, which is really cool. If we want to schedule alerts, right, we can do all of that in terms of a job. If you have DBT, I have a lot of customers that run DBT natively with Databricks. We fully support that as well through the partnership. If you just have wheels or jars or clean rooms, we can orchestrate all of that as well. And like I mentioned earlier, how do we keep our downstream dashboards? If we want to update semantic models, how do we keep all those things aligned? A Databricks job is your friend for that. Notice in my case here, I'm not actually going to create a job, but if we go back, we should have a job that is running already. Again, mine's called DB Demos Retail, and we see that we have multiple tasks here. Let me see if I can zoom this in. Boom, 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 boom. There we go. So we're not only just going to be loading data, this is loading in our raw data files into our volume. Then we kick off our pipeline. Then we're going to be doing our downstream dashboarding and machine learning work as well, registering our model, and then making our inference, and then adding in some AI large language functions as well. Cool. So while this finishes running, let's wrap up with a couple of other topics that I have here. Let's pop back over into our notebooks. One last thing just to close out Spark declarative pipelines. If you've been around Databricks for a minute, you probably heard about like DLT, all that good stuff. So declarative pipelines is the open source and next generation version of Delta Live tables. And you may also be more familiar with the Python syntax. So I wanted to quickly show what the Python syntax looked like for defining these pipelines, as this is more often what I see in the real world as well. So yeah, notice that the syntax is crazy, completely different, right? And that's because it's the Python implementation of Spark. But because we have these frameworks of declarative pipelines, we're able to have the expected paradigm of what the downstream architecture would look like. So again, similar deal. In this case, we're using a Spark read stream to be loading in from the volume. And again, same idea, whether we're inferring column types, we're adding in our expectations, we're adding in comments and descriptions. All of that can be done in Python as well. I don't really see any difference in the PySpark or the Spark SQL. The PySpark is a little bit easier to work with for machine learning. You'll notice that we didn't have to have a separate like declaration of our predict churn UDF. You can't really declare these UDFs in SQL, but you can in PySpark really easily. So we're able to incorporate everything there as one object. Cool. I know we want to run some code, so let's run some code while our pipeline finishes up. So what I'm going to do here is I'm going to close all my notebooks. And let's run into the data governance piece. So I'm going to open up folder 2 and I'm going to open up 2.1, which is our data governance notebook here. So we should be able to run this as we go. So let's go ahead and do that. I'm going to connect to our serverless instance here. And then let's play around with what we can do with Unity Catalog. So I'm going to go to run, clear all cell outputs. And we should be able to play around with what we can do with some RBAC and ABAC queries. All right, so the challenge is we now have this beautiful data architecture that we've already laid out, and we can already see it in action, right? All of our tables that we talked about that we were loading, we're up to 10 tables now, right? And we'll take a look more into what these tables are doing after the governance section. But let's say we wanted to add governance. We wanted to add ACLs, audit logs. We wanted to look at the lineage, the exploration. How can a Unity catalog be our main data catalog for that full governance of our data and AI assets? So again, I'm going to run these cells in order. I'm not doing run all just because we may need to add ourselves to some user security groups to see how the RBAC and ABAC responsibilities actually play out in the real world. So let's run our first couple tables or cells here. We're going to notice that if I run show tables, it should show me all the tables within my current catalog. So we should be able to see, yeah, there we go. We have all of my app events, my bronze tables, my silver tables, my gold tables. They're all here within my workspace. And again, like I mentioned earlier, if we actually go back to our catalog, so I'm going over to my catalog tab. You don't have to follow with this. But I do wanted to quickly show you that if we looked at some of these tables, I'm going to look at churn predictions, which is our most downstream table. If I click on lineage here, we should be able to see a full lineage graph of how different tables and columns, we can see, there we go, right? We have multiple tables that are being joined together, and we can even see whether something comes from a volume or not. All data and AI assets, there we go. We can see the volumes, the different Google storage buckets underpinning this whole thing that are then powering the flow of the tables. So again, we'll do a little bit deeper dive into this lineage here as we run through this notebook as well. But again, how do we make sure that we only have the right permissions to access certain objects? So here we go. Before we run this next cell, let's talk about user groups. So in Databricks, we allow for user groups to be ingested directly from your security SIM, whether it's Okta, Entra, or even through Google authentication. But I think for this example, we just created a couple basic ones inside of the workspace. So let's showcase how to do that. So let's click on our icon in the top right here. I'm going to go to settings and I'm going to open that in a new tab. This is where not only can you mess with previews as well as your developer experience. For example, if you want to turn off dark mode or turn on dark mode, you can do that here as well. But if we go to identity and access, this is where we can start managing user groups as well as creating service principals. So for the sake of this demo here, let's pivot into our groups and you'll see that I already created some. But let's, in case you haven't already, let's create a couple. Let's create a group. I'm going to call mine analysts. I already have one called analysts. So I'm going to call this analysts 3. In your end, please just call it analysts if you don't have a group called analysts already. I can't remember if the lab creates one for you. So if you do already have a group called analysts, that's totally fine. But otherwise, you can create new groups there. And then once you have a group, either analysts or data engineers, if we click into it, we should be able to add ourselves. So I'm in my analyst group. Let's add members. And I'm going to just grab all account users or whoever my name is. I think it's just Alex. I'm already added to the group, or AB. That's why it hasn't found me. Yeah, there we go. So I'm just adding myself as a user into the analysts group. One thing to also note is that I have a last group called retail admin. I'm actually going to remove myself from this because that's going to be how we do the demo. So essentially what I wanted to show in this demo here is how do we make sure that if I belong to one user group, I have one set of permissions on the table. But if I belong to an admin group, how do I have additional requirements on the table? So again, all that we've done so far, we've gone to our profile, we've gone to identity and access. We should have 3 groups here, or at least 2, at least one called analysts and one called retail admin, and preferably one called data engineers. And then add yourself as a user to the analyst group. So I'll give you a minute to do that while we go over to our to the notebook. So you're going to see that the cell that we're going to run here, and I haven't run it yet, but basically we're going to be granting select ability on our silver tables to the analysts. And then we're actually granting full modify permissions on the schema to the data engineers group. So we have, this is our role-based access controls. Depending on our role, we have different access controls on the underlying tables. And all these permissions are navigated through Unity Catalog. And what's kind of cool too is that this totally works on volumes or machine learning models or even like AI agents or dashboards. It's the same security rules and security policies. What do I have access to interact with if I belong to one of these different roles? So we're going to create a new table real quick. So I'm going to run through these next 2 cells. Essentially, all that we're going to be doing here is that we're going to be adding in a row filter as well as a mask, right? So here's why I don't want us as part of the admin group. If I'm not in the retail admin group, I'm going to see stars. Otherwise, I am a group member. I do have the role access of retail admin. Then I'll see the underlying column value. So you're going to see we're going to add this masking function against my email, first name, last name, and address. So when I select star here, let's kind of do the workflow, right? I'm part of the analyst group, not retail admin. So I should see my masked columns here. There's other ones, right? Like we can look at row-based filters, right? Depending if I'm only I think non-retail admins can only access US. So since I'm not an admin as well, I should only be able to see US-based rows. So we have 2 options going in here. We have a role-based access control around masking, as well as a row filter, also based on my role. So let's run the cell and cross your fingers. And oh yeah, I didn't actually make the right, what is in the like? I want to, oh yeah, the table doesn't exist. Drop table if exists. Look at us live coding. Drop table if exists, and then we're going to create the table. You could also just comment out that line if you want. And now let's add in our role-based table definitions and run our select star. So if all goes well, I should see masked columns and I should only see US rows. Oh, there we go. Live demos. Hooray. Look at me. Let's go. Woo. So there we go. We can see our mask. We have these star asterisks for our email, first name, last name, and address. And if I do a quick look at the country column, our row filter has also been applied. We only see USA. So for the full sake of the demo here, if you go back to the groups, you can add yourself to the admin group. And unfortunately, this does take like a hot minute for the permissions to update behind the scenes. But we'll let this update itself for a minute or two. But if I go back and then rerun this query, I should be able to see everything. None of the masking or the US stuff as well. I'm just checking my run again to see what's taking so long. It's still having a tough time allocating that inference allocated. Anyway, hopefully this is running here soon. Oh, it's doing something. All right, so that's still going. So hopefully that'll be here in a minute. All right, so anyway, let's go back to kind of what I wanted to show. So far what we've done here, we have gone from 0, we've gone from raw data sources in a volume. We've run our declarative pipelines to ingest that raw data to find bronze, silver, as well as our gold level tables. And we've looked at the lineage. We've also created access groups in which that we have defined different governance and run them on top of the data here. So I think we're probably good to take a quick break. Let me confirm. I think we did everything. Oh, let's just try rerunning this and see if my admin permissions have been applied yet. That was me stalling for a minute to try and let those permissions get activated. Let's take a quick break though. Let's be back. Yeah, it hasn't updated yet. Let's take a quick break. Let's be back in about 10 minutes, so maybe the top of the hour here. I wanted to quickly showcase some of the machine learning stuff for about 15, 20 minutes, and then we'll close it out with half an hour or 45 minutes or so on the AI BI SQL. So get up, stretch your legs, get some water, shake it out a little bit. And then when we come back, we will tackle some of the ML AI stuff for the last hour here. And I will check the kind of chat and the Q&A. Cool. We still got over 100 folks on board. So thanks for sticking around, y'all. I know this is like a 3-hour walkthrough. So it takes a hot minute for sure. All right. So remember, we're on break for about 8 more minutes. So I will do one last pass. Looks like we're good for Q&A. So I'll also kind of just stop talking. Until my permissions come through. If you are sticking around though, and you want to click around a few things, again, we are officially on break. It is we have another notebook in the governance folder around metric views. So we've talked a little bit in this lecture already around semantic layers and defining options. So this is a good notebook to create a metric view. Again, a metric view is a object within Databricks' definition of a semantic layer. And you can kind of see that we're defining different dimensions as well as measures, and some of our measures have SQL functions assigned to them. And this way, if anyone or the AI asks, maybe you ask like, hey, give me all active users in my database. We already have a strict definition of what does an active user actually mean. So in this case, we don't have multiple conflicting definitions of this measure, right? We just have one definition that's then saved into our semantic layers. So pretty cool. And again, these metric views, they can be centrally saved in part of your data architecture, and then they can be referenced by multiple downstream consumption objects, whether it's a Genie space in AI, whether it's a dashboard, right? All of it can or be, or the AI assistant, all that can be consumed via um, uh, the centralized metric view. The other part to this as well, as we were talking about, let me go my catalog again. If I look at the overview here, you see that we have like a description already, and that we could add in AI comments. So let's actually do that again. It says to improve our semantic layer. If I clicked on churn orders, for example, notice that we can AI generate different columns here. So this is a pretty lame table. Let's grab maybe the app events. Yeah, there we go. So let's see if we can AI generate some column descriptions. Let's make sure that our warehouse is turned on. I mentioned that like the SQL warehouses are only good for SQL queries. Well, a lot of our AI functions operate as SQL queries, which is really cool. So when I AI generate our column descriptions here, there we go. Look at that. That was so quick too. This is actually running as SQL behind the scenes, which is pretty neat. Yeah, this is all bonus topics. You're still on break, and this is all recorded. But I wanted to show this to come through because then I wanted to show you one of the new kind of AI Discover powered features we have. Cool. So that did save. And as I look now, I have my comments added for all of my different columns. Right. So, and why we recommend adding these comments is because when we do create AI powered Genie and dashboards, which we'll see in the last hour here, it's going to be pulling from those semantics. And in fact, if I go my left hand pane, if I click on Discover, for example, this allows us to find assets, whether it's tables, whether it's dashboards, whether it's Genie spaces, or even pipelines and jobs. And this is all based on your semantics. So if I wanted to find something like events, right, I just start typing that in. It's going to be pulling from the table as well as like columns and names. So here we go. We can see that this churn app events, right, events that I searched for, it matches the column description that I typed out, right? Or that AI, I guess, generated for me. It represents the date when the event occurred, right? So we can filter any like on that, which is pretty nice. Notice that we can also like certify tables as being good or not. That's also kind of fun. So let me show you that. We still got about 3 more minutes, so don't feel like you need to listen to me right now. But if I go to quality or not quality, if I click on the three dots next to the table, I can assign certification on like whether or not this is a deprecated table or whether it's like good, that it meets my organizational standards. Hurrah. So again, typically I recommend having your gold tables either be marked as certified or deprecated. That also allows you to keep the history if you have like a bad table that you don't want people to use anymore. We can just deprecate it instead of completely deleting the table. So if we've certified the table, there we go. We got our little blue tick mark. We didn't even have to pay Elon and Twitter any money for it. We got a little blue check mark next to the table. Sorry, that was a lame joke. And if I go back to my Discover, we can certify, we can search by certified, and there we go. We have a certified tag. Oh, that's a good point. Maybe we can show tags as well. Not only can we just have descriptions, but if I scroll down on my table, you can see that I can add in different tags here, as well as policies and row filters and things like that. So I like adding tags to my stuff. We can add in like a new key, whether like we can also have like governed tags, which means that like it's a single source of truth for a tag to basically be uh, we always want to include like the class or something. But we can just add in like an other tag as well. Let's just do one that's maybe like data team or something. So we're creating a new tag, and now I can say that this is made by, I don't know, the Fan 360 team. So I know who supports it. So now as like an admin, an administrator, I'm able to quickly filter that, okay, I only want certain domains or certain teams. What tables do they manage, or what tables should they be referencing downstream in terms of different groups? So pretty cool. A lot of good governance we can do. Oh, and I mentioned we could also do governance on the volumes. Exact same deal, right? If I click on the volume, I can add tags and say like this is the data owner, or what did I call it? Data team. Yeah, data team, and we can set that to be the fan 360 group or something. We can also fully restrict like permissions on volumes. So like I can grant or revoke access to different user groups and roles. So let's say I want to grant like all privileges to the data engineering role, right? This is already like a thing, which is why it's thrown me some warnings, but whatever, we can still grant it, right? So again, a lot of really cool granular permissions we can do. And I also mentioned this can also happen on machine learning models, that we'll show here in a sec. Oh, there we go. We got two versions showing up. Same idea. We can add in descriptions, right? An AI generated description of the model of whatever it's doing, as well as adding in tags and deployment things. So I really think that what sets the Databricks governance catalog apart is that we are really able to have the same flow to govern and manage everything in your data ecosystem, from the raw files through all the different tables to even the machine learning models and Genie spaces and dashboards that you create. All right, I got about 15 minutes here. We got 1 o'clock. So let's have, or I guess 12 o'clock, 11 o'clock Pacific. So we got 11 a.m. Pacific. So I think we are back here for 1 more hour. You're with me for about 15 more minutes. And then I swear you'll be out of my hair, or I'll be out of your hair. And we'll pass it off to do SQL and AI stuff. All right, so for my second act here, or for my third act, whatever you want to call it, we're going to take a quick look at the machine learning notebooks and the machine learning work. So I'm going back into our workspace that we've already kind of looked at with some of the governance things that we've discussed. And let's click into folder number 4. So we're popping all the way down into 4 here. And I wanted to run through a couple of notebooks. So again, we're not going to run these either. You could, but just know that these machine learning notebooks take a long time to run. Point being about my inference job failed again. Let's see if we can repair it. Also, I had some trouble getting this stuff to run before the lecture as well. By the way, these take a while to run, so we're not going to run them either. We're just going to kind of talk through them. So we're going to put on a different hat here. So before we've been running as a data engineer. Now let's put on our data science hat. What our job that we need to do is we need to be able to try and create and iterate on machine learning workloads based off of these data pipelines, right? So Mark, as the data scientist, needs to be able to grab data from the Spark declarative pipelines, create features, train models, deploy the model onto serving endpoints, and monitor that model for drift in terms of the model. So one thing that we can do is run our auto ML feature. So we have kind of an auto ML option for predicting for within the Databricks use case. So in this case, we're basically just reading in a few different libraries, loading in our churn features data set. And then you can see that we have all of the different features that we've already curated from our Spark declarative pipelines tables. So again, this is the 1 row per user, where we have all of the different options that could correlate to whether or not a user churned. From there, we're able to look at some analyses. In this case, I'm just using Seaborn to do some quick distribution plots. And now we can convert into the pandas syntax. And if we wanted to, we could implement with our Databricks feature store. From there, we're able to interact with whatever data has already been stored and use that for live inference. Our feature store is, you can run it as a Delta table, but you can also store our feature sets in our new Postgres offering, our OLTP, which is called a Lakebase, which I'll show here in a second as well. Cool. So what our OLTP does essentially is like a feature store is essentially just a fancy table of that's optimized for querying at inference time. So it doesn't really matter where it lives, whether it's in a classic Delta table or a feature store table within Databricks or even our Lakebase Postgres instance. Multiple opportunities there. And then from there, we are then able to run our AutoML project, and we're able to run this classification. And again, this is going to create an experiment behind the scenes. And we can see that the result of our experiment is all this work, all these options right here. And the model that gets generated gets saved off in our experiment. So again, if we go back to our experiments, there we go. We do have this AutoML option. So again, if you didn't see this at the beginning, you should hopefully see it now. We're able to create this experiment. We can see that it's a light GBM experiment. And from there, we can see all of the results of the model. So pretty good stuff. Last thing that we did was that the model then should be saved. So if you didn't see it earlier, I do see it in here now. Here is my model. Oh, that's my old model. Here is my new model. And we can see that this did run and created a new version that has this prod alias. Once we have our model, like I said, this is fully brought into the scientific method. We have the full hyperparameters, the full performance, everything is fully visible. And from there, we're able to tie this back to a deployment. So if I look at our model serving, which should be all the way down here at the bottom, we're not actually serving it, but we could, if we wanted to containerize the model, have it as an API and then preview it. But in our case here, our whoops, that's the wrong notebook. In our case here, our model is only used in terms of that AutoML generation. If you're curious, I always never trust the AutoML that gets generated. So you can actually see the notebook that the AutoML and AI generated behind the scenes. So this is all AI generated, AutoML generated code. So you can see it does the full pipeline going from your column selector all the way through to your model selection, and then puts it up into full feature importance and full transparency and around what was actually used to train the model. So very cool stuff. Finally, the inference notebook. Again, in this case here, we're reading in the model as a object within the model schema. And again, we're connecting it back to the requirements. You can see we're pulling it directly from our model host, from our registry, and then using that to register our prediction function to predict churn. If we did have this hosted as an API endpoint, we wouldn't have to read from the model artifact. We would just read from the deployed serving containerized endpoint. Cool. So I think that's all I got for the machine learning section. I know I kind of flew through that, but I didn't want to really run into any of the code here, and I wanted to give plenty of time to Kunal on the line here. So Kunal, are you ready? Do you mind if I pass it on over to you? I don't think I have too much else to go over here.
That was perfect. Thanks, Alexander. You got us right back on time.
Sweet.
Awesome. Thanks, Alex. Good morning, good afternoon, everybody. Hope everybody is well. Give me a sec while I share my screen. All right, second. All right, so you guys can see my screen. Let me minimize some other stuff. So now we've talked a little bit about data ingestion. We've talked a little bit about how to get data into Databricks, and we've talked a little bit about once the data is there, how do you transform it? How do you get it ready for some machine learning models? How do you run some experiments on it? How do you enrich the data? And now the final cog in that wheel is, well, now the data is there, now the data is enriched. How do I take action on it? So let's talk a little bit about a warehouse on Databricks and also some analytics using AI BI. And if you have questions, please feel free to stop me. I'm going to try to monitor as well. I want to try to go at a slower pace. So conceptually, first we got to talk about the warehouse. Traditional data warehouses are have only worked with structured data, right? But in any enterprise, in any company right now, you've got so much data that is not just structured data. You've got unstructured data as well. I work in the healthcare space, and we've got X-rays, we've got PDFs, we've got doctors still taking notes on a piece of paper and pen. You've got a lot of that data that is there, and how do you bring that in, and how do you start using some of that data, combine that with some of the structured data you might have, and start making meaningful sense out of it. And that's why we feel Databricks Lakehouse is the best warehouse, because now in the Lakehouse, with access to your structured data, your unstructured data, maybe some enhanced, you've brought in all this data, you're driving some machine learning insights into it and enriching that core data set with some insights from the machine learning models. Now you can combine all of that stuff, and now you can actually do some analytics on top of it. So architecturally, you're bringing in your data, you're bringing in your schema, you're applying governance on top of it. You're using Unity Catalog, which is kind of our secret sauce. You kind of define who has access to it, define controls, define policies. And on top of that, you can create your serverless warehouses that now go and service. You can consume that data from some other BI tools. Tableau and Power BI are some of the more popular ones. Looker is a really good one too. And in fact, I think Looker just changed their name to something else. And then we've got our own built-in BI experience as well. We call it AI BI, and we'll definitely experience that today. And you can also experience that through other applications. All right, so it's the best-in-class BI engine. We've done some benchmarks out there. We actually performed really well at a high scale, so at high concurrency. When you have lots of data, you have lots of users, you have lots of concurrency, that's when we shine the best. And it's not just us saying that. There's a lot of benchmarks that have been done. I encourage you to check it out. All right, so the first thing we're going to do is we're going to create our warehouse. And as Alex pointed out, we've got two different kinds of compute. One of the compute is for running our SQL workloads. It's called the SQL Warehouse compute. It's already created for you in this free version. All you got to do is start that up. So I've started up my compute, and I'm going to go back. And if you think about a dashboard as the end goal for consumption of your data, a dashboard is simply a collection of multiple different reports or queries or data sets, whatever you want to call that, underneath the blanket, right? So before we talk about a dashboard, we got to talk about queries. And in my mind, before we talk about queries, we got to talk about our tables and what kind of data do we actually have. So what I'm going to do is I'm going to go back to my catalog. I'm going to go to my workspace where my schema, where my tables are. And this might be different for you. You might actually have followed the instructions as Alex was talking about and created your schema in the main, in a different workspace, in a different catalog. Mine is in main. So my tables are in main schema. So I got all the tables out here. I want to take a look at some of these tables. So I can come here, I can go to sample data, and it's going to show me what kind of data exists in my table. And I think it's important to understand that before we start looking at some dashboards. Give it a sec. All right. So we got user, email, their activities, their address. So this is kind of dimensional data for that user. Let's look at orders. And orders, once again, I think it's going to be more of the actual metrics and data. All right, so essentially order count. When was the order placed, I suppose, and order ID and how many items were bought for in that order. Now the cool thing is, and I won't go into too much today, but as you're playing around in your free edition, we've got Genie infused everywhere, and Genie is essentially our attempt at infusing AI in literally our entire experience, whether you're a data engineer, you're a governance engineer, you're a data analyst, you're a machine learning data scientist, doesn't matter. Your experience is enhanced by using AI features in there. So All right, so now we kind of know what kind of data exists in our tables. I want to go back to where we talked about queries, right? So in our dashboard, one of the first things we do is you got to create a query. And you can simply create a query, and this experience should look very similar if you've been working with SQL tools and databases and warehouses in the past. It's a simple SQL editor. You could start typing like, hey, select star from, you know, orders or whatever your table name. So actually, I want to change make sure you're in the right workspace. I'm in main and I want to be in the right schema. And I want to say, hey, select star from churn orders, and I want to show everything. And this might take a few seconds for it to run, right? But I think some of the other cool things are that now I don't have to just rely on writing the SQL queries. I can actually use AI to also add some parameters to it, right? So if I wanted to go there and if I want to edit this and say, actually, show me the top 10 item counts, instead of actually me going and changing the query, I can actually generate my SQL query using AI and have it do it. Obviously, this is a very simple example, but you get the answer, you get the idea as to what you can do with it. And some other ways you can do it, like I've got some customers who are now migrating some of the code from SAS to Databricks, and when you run some of this code, you might get some errors in there, and you can also use AI or Genie code to sort of start debugging it for you. You can be like, hey, find the errors, diagnose this error, and tell me what I should do. So anyways, you get the idea what's happening out here. I'm going to go back to my notebook and follow along. All right. So the next step is, well, now you kind of know how to run queries and what queries are and how to create them. Then we can create our dashboard. So for this example today, I'm just going to show you one that's created. I highly encourage all of you to actually create one. And we'll do a little bit of that right now. And I want you to see how easy it's become in our experience to do it as an end user. All right, so you're looking at this dashboard. This dashboard, like I said, is nothing but a collection of data sets out here that kind of form the basis of what the dashboard is going to have. And obviously you can, now when you come here to the visualization page, you can now start creating some of these visualizations. You can add a visualization. I don't know if you can see me hovering down here. You can add a visualization, and when you add a visualization, you can select what the data set is and what it should look like, and you can select all the different properties on the right side. But what I want to show you is something how our customers are beginning to change how they develop these dashboards. Instead of actually figuring out what's going to go on a dashboard, you could come to Genie code. Genie code now has Genie code is think about that as an agent, is your development. It's an agent that's going to help you as a BI developer to build or to answer questions about your dashboard. And the context it has is all the different data sets that you've provided it. So now, as a BI developer, or maybe even as a data analyst or a business analyst, I can come here and I can be like, well, there's a lot of data in here. What are some interesting questions I can ask from this data, right? And I think what Genie will do is it's actually going to go back, look at your data, look at the dimensions, look at the metadata around it, and try to come back with, or based on all this data, these are some of the things that might be useful for you to consider. And it's not just that, it can actually give you suggestions on, hey, do you want me to add this? It's like it's saying, hey, do you want to add this to your dashboard? And I can say like, you know what? Yeah, add show revenue lost from churned customers. And now it's gonna create some of those metrics because they just don't exist right off the bat, but it's gonna understand how to create that math. It's going to write that SQL. It's going to create a new data set for you. And now it's going to add that to the dashboard as a visualization. And I think that's kind of the acceleration you would have as a BI developer or as a data analyst or even as a business analyst using AI BI as your dashboarding experience. So it's pretty powerful. It's especially powerful if you actually want to go one step further, right? So the one step further would be that this, as I mentioned, this dashboard kind of becomes a contained experience that you might want to provide to your end users, your business users. And you can see it added these 3 containers out here. So you can expose this dashboard to your business users. You can publish this dashboard and you can expose it to your business users. And I'm gonna show you what that experience looks like in just a sec. It's not an exercise, but I'm gonna show it to you. And the value of that is, as a business user, I don't have to come into and see all of this noise of Databricks that is more for developer experience. I'm simply going on to a web portal where I can ask a question. I can find my dashboard, I can ask a question. So we'll see what that experience looks like in just a sec. And I'm gonna just publish this, which means that it's just going to save it and who has access to it. And I'm not gonna change anything out there. All right. So let me go back to my script for a minute, and then we'll come back to the experience I was talking about in just a minute. All right, now you can use third-party BI tools. We talked about connecting it to Tableau or Power BI, and you can use those tools to consume this data from Databricks. The compute runs on Databricks. The visualizations go in vendor in your BI tool, and you can do query federation, data ingestion, so on and so forth. You can do that as well. All right, what I'm gonna pivot to. I'm gonna move to the next topic, which is the AI BI Genie. Right. So Genie has been in our product for some time now, and now we're consolidating a lot of our different agentic and GenAI features into Genie portfolio of products. And there are really 2 experiences I want you to think about over here. One is Genie Code. That's what I was showing you right now, which was more of a developer experience of, hey, help me do this, or help me check this code, or help me diagnose this code, or help me write this Python, or help me write the SQL, or maybe, is there a more help me optimize my SQL? You can do all those things using Genie Code as a developer experience. But then we also have a user experience called Genie. So Genie Genie allows end users to ask business questions in natural language, translates the text or natural language to SQL, goes and runs it and brings back data, infers the data and brings it back, right? So we'll walk through some of that stuff. Just like a dashboard we talked about dashboard having some preset visualizations in there, but it's got a foundational few data sets that go into it that formulate the dashboard, and now you can ask questions in the dashboard. We've also got a new experience, what we call as just the Genie experience. And really what that is, in its absolute simplicity, is you take a bunch of data, you identify a bunch of tables, and you say, these are the tables that have relevant information for me, for my customer, for my business user. And you put those tables into a room. And now in that room, your business users with a very easy to use and easy to understand Google-like experience can just go and ask a question. And that gets translated based on, your data lineage, your data model. All that gets translated by Genie and then gets presented back to the user. So let's take an example and let's run it. So what we're going to do first is we're going to create a Genie room and or Genie space. The terminology is changing here a little bit. So how do we create? You can either use one that's already created. I think this one is out of the box. You might have it in your free edition as well. But actually, I want to just go ahead and create one. And it says, well, what kind of data do you want to bring in? And in my case, I want to bring in some churn orders. I want to bring in churn users. I want to bring in, let's see, let's bring in some events. All right, so, and that's it, right? Your Genie space is created. Now, obviously, this is just the foundational stuff, like automatically based on the metadata, based on some of the information that you've already defined in your data model and Lineage. Genie space is trying to create those connections and figure out, hey, what is this space going to be? What kind of data is here and what kind of things can you do? And it says, well, based on this information that we've seeded this with, this should be able to give us customer churn insights, right? So, and it's even saying, these are some of the questions you can ask me, right? And this is all based on the metadata that you've already defined. And that's kind of the magical aha unlock that happens for institutions is the more you invest in creating your metadata, enhancing, enriching your metadata, giving it meaningful context, the more it's going to help you with all of the AI stuff you want to do later on, right? And that's kind of been the evolution. How do you minimize how do you minimize hallucination? How do you maximize quality? That's how you do it. And out here, obviously, this is just foundation. Like I've already created a Genie space, and now you can go and ask it questions. But you can also tweak it. You know, there are many ways to drive better quality of data in your Genie space. You can configure it. There's a lot of instructions. There's a lot of things you can do to configure it. There's something called as metric views, which is essentially you can create some definitions of metrics and calculations right back in your semantic. So you're essentially creating a semantic layer close to your data. And that's sort of a different paradigm to creating it in the BI tool. So if you're any of you out here use Power BI or Looker or Tableau, you're defining what are my top claims? What's my count of orders? What's my churn percentage? You're creating that semantic layer close to the BI tool. In this case, if you actually create your semantic layer close to the data, you have more control over it, you have more governance around it, and now you can actually use it anywhere you want, right? So you could bring in those curated definitions in here. I'm not doing it for this demo, but you can bring them out here. Now you're here. Now you can actually ask a question. You can say, hey, what app platform has the highest churn? And Genie's going to go back, it's going to reason, it's going to go through the data, it's going to try to reason through it and come back with an answer. And it's actually quite fun to watch how it does this reasoning. So let's give it a sec to come back to us. And we can expand this reasoning as well. And while this is doing it, I know we're running short on time out here. I want to show you what the end user experience looks like as well. So this is kind of, you're talking about a developer experience. We're talking about a business analyst experience. All right, so this came back and said, all right, well, churn rate by app platform, we've got, 66% at, and they're pretty much the same across all the platforms. So there's no one clear, like, hey, platform that has the highest churn, but there are other factors you might want to look at. All right, moving on. So if you click on these dots over here, this hamburger menu on the top, you could go to Genie, and this kind of shows you a simplified version of what your business user might see. There's no more all the Databricks, like, developer experience stuff on the left side. This is a business user experience where they have access to a chat-like experience. What do you want to know? Or if you want to come in and you've got a bunch of curated assets, like a bunch of dashboards, like I, as a business leader out here, I have multiple different dashboards I go to on a daily basis, and I don't have time to go find it. I can come here and be like, hey, I need access to this sort of information. I'm looking at my consumption forecast for product. I can simply come here and search, and it's going to go find me the right asset for it. Or I could just come here and ask it, be like, hey, what is the demographic makeup of my highest churn customers. And I mean, I've never asked this question, honestly, so I don't know what's going to come back, but it's going to go and based on the question, it's going to infer, okay, where can I find this question? Can I find it in the data set? Can I find it in the Genie space? Can I find it in the dashboard? Where is this information? Then it's going to try to see if I can create a SQL query to extract that information. Then it's going to infer it, and then it's going to bring it back to you. So it's been a huge unlock for us. I mean, my customers are using it every single day. They can't get enough of it, quite frankly. And it's been a massive shift in how customers are beginning to use data and AI. I can tell you my own experience as a business leader. I almost think dashboards are dead, quite frankly, because I don't need to go to a dashboard. I can simply come to Genie. I have it on my phone. Actually, this experience and as an app, and I literally go in the morning and I go and ask it a question like, hey, what was my highest consumption across all my accounts yesterday? Which workspace did it come from? What's my breakdown between the different hyperscalers? So you can ask questions and it's going to come back and bring it back to you. So let's see how this comes back. What comes back out of this? I haven't tested this out before, but hopefully it comes back with some decent information. All right, so demographic makeup of high-end customers. We've got 45,000 customers. 67% of gender 1. So in our data, we don't have dimensional data for what that means, 1 or 0. So it says while 32% are the second, the lower gender population has the higher churn rate, which I think is really cool information and something that if I was looking at a dashboard, this might not have been totally obvious to me at first glance. So this, I mean, like I said, for me has been a huge unlock. I'd encourage all of you to take some of your data and anonymize it and put that in the free edition and play around with it, because I think it's going to come back with some really cool stuff. And the pretty cool thing is that we have access to this for free in the free edition. All right, that's what I had to show. I'm going to stop my share. Are there any questions, or have we answered those questions? Bonnie?
We are 100% answered on all of the Q&A.
Awesome.
Yeah.
Do you want to wrap this up, or should I?
Yeah, I think so. And I'll give it like 1 minute. I do want to call out that I launched the end of session poll. So it would be amazing if you could all complete that. It'll take less than a minute. It's 3 questions and just really helps us make the content more impactful and get insights into how you all perceived the workshop overall. So please take that before you jump. Otherwise, I want to thank Kunal and Mofeed for all the Q&A answering, and Alex, who's no longer on the line, and Taylor for hosting the slides initially. Thank you so much for joining us. You'll receive the recording and slides within 1 week.
Thank you, team. Thank you, everybody.
Thank you.